This is Chapter 3 Geometry that largely deals with parallel lines. There are actually more than one type of lines which don't intersect, because we can also have lines called skew lines. So for both of these, they're both lines that do not intersect. That's both for parallel and skew. The difference is parallel lines are lines in the same plane. They are coplanar lines that do not intersect, whereas skew lines are lines that don't intersect, which are not in the same plane. So you can be given diagrams, for example, a box, and from this box you could be named to ask lines which are skew. So skew are two lines that don't intersect but are in different planes. So if I look at that vertical line EA, if I look, say, the top back edge AG, those are lines which definitely will not intersect, and they're different planes, so they're called skew. If I ask you to mention two parallel lines, I need lines in the same plane that don't intersect. So I could choose line and line segment EA, and the one on the back left wall with it, we could say parallel to HD. The bigger part of this lesson is if we have two lines and a transversal. We have three very important types of angles which are formed. We have corresponding angles. They're angles in the same relative position to the two lines in the transversal. We have four pairs of them. Angle 1 and angle 5. Think they're both above the line and to the left of the transversal. And then the ones below each line and to the left of the transversal would be 3 and 7. And the other two on the right-hand side of the transversal would be 2 and 6 and 4 and 8. So those are corresponding angles. Separate from corresponding angles, we have alternate interior angles. Since they're interior angles, they're angles that are inside the two lines. So if we have line A and line B, they have to be inside those lines. So those interior angles are 3, 4, 5, and 6. The alternate interior angles are 3 and 6. Think the top left, the bottom right, and then the other ones, that is a 4, would be 4 and 5. And the last type are called same side interior angles. Once again, if they're interior, they're inside, so it's 3, 4, 5, and 6. They're on the same side of the transversal. There are two sets of those, and those are 3 and 5 and 4 and 6. Don't forget, you also want to think about vertical angles, such as 5 and 8, 6 and 7, 1 and 4, and 2 and 3. So example, 5 and 8. We know vertical angles are equal. And then you also want to think about linear pair. So when you see a diagram like this, you want to think of half circle. So angle 1 plus angle 2 equals 180. And there are many other relationships, such as angle 2 plus 4 equals 180. Well, corresponding angles, alternate interior and same side interior angles, even if those lines aren't parallel, they still have those names. But if line A is parallel to line B, Now we have different relationships for those angles. If the lines are parallel, the corresponding angles are congruent, and that is called the corresponding angle postulate. The alternate interior angles are also congruent, and that's called the alternate interior angle postulate. And the same side interior angles are supplementary. I'm sorry, one correction. The alternate interior angle is not a postulate, it is a theorem. The only one that's a postulate is the first one, the corresponding angle postulate. And then the same side interior angles are supplementary. They add up to be 180, and that's called the same side, I'm going to abbreviate, interior angle, and it is also a theorem. So you can be given many problems that have algebraic relationships. Be given algebraic expressions, and from that you have to determine the measure of various angles. So if I gave you this with these two lines being parallel, if I said find x, you could say 3x minus 6 equals 2x plus 12. Solve for x, so x equals 18. If I gave you two parallel lines, if I give you 3x minus 6 and 2x plus 10, the equation you'd use to set this one up would be 3x minus 6 plus 2x plus 10 equals to 180. I'm not going to solve that. And other relationships are true as well. What students have problems with sometimes is when there are diagrams that deal with triangles or parallel lines. They sometimes get confused. Once again, my rules are if you have three angles, you want to look for, if you have two angles in a triangle, then three angles equal 180. So if I give you two angles in a triangle, as soon as you're given two angles, you immediately want to find the measure of the third angle. So in this diagram, if this is 61 and this is 60, you can determine this one is 59. If the lines are parallel, we know the alternate interior angles are equal. So I see 61 here, so therefore that's 61 degrees. And if we look at angle addition postulate, it's a 180 degree rotation. We can find that missing angle, since all three must equal 180. 61 and 59 is 120, therefore that missing angle is 60. You want to consider vertical angles. You want to consider linear pair, angle addition postulate, to add up to 180 in all diagrams. And you want to add up, if you have a triangle, we know the sum of the three angles equals 180 degrees. You also have to prove two lines parallel. If you have to prove two lines parallel, you want to work backwards and say if the lines are, if they were parallel, what would be true? So if I give you line A and line B, and you see something like this, and I say prove line A is parallel line B. You work backwards and say, well, what would be true? What is the goal you first want to prove? Well, in this diagram, I can't state 1 equals 3 because we don't know the lines are parallel. But if I could somehow reason that angle 1 equals angle 3, then I would know that the lines must be parallel, and that's by the converse of the corresponding angle postulate. There are actually 5 ways to prove two lines are parallel. 3 of the 5 are very easy. They're all the converse of the theorems we know. So it's the converse of, for the first three, converse of the alternate interior angle theorem, converse of the same side interior angle theorem, converse of corresponding angle postulate. If you knew the alternate interior angles were equal, or the corresponding angles were equal, or the same side interior angles were supplementary, you could say the lines must be parallel by the converse of those three theorems. The last two methods are, if rarely used, if you know two lines are parallel to a third line, then we know those two lines must be parallel. Or if you know two lines are perpendicular to a third line, then those two lines must be parallel. One thing that students have problems with are diagrams when you're told or asked whether or not which lines are parallel. Given information, this is where I say you should sweep the angle. So if I give you, for example, if I give you that angle 1 and angle 2 are congruent, which lines, if any, are parallel? Remember, two-dot rule, you sweep angle 1, you sweep angle 2, put the dots where the two dots are on line AD, that's my transversal. Where's the other single dot? One is on AC, and the other, put a letter F, the other is on FD. Therefore, we could say that line AC must be parallel to FD. The reason for that would be those angles are alternate interior angles, so that would be the converse of the alternate interior angle theorem. Look at that for more practice as well. And then section 3.4, section on triangles. Basic things on triangles. All three angles equal 180. This is called the triangle sum theorem. All three angles sum to 180 degrees. You need to know the words for scalene, no sides equal, isosceles, two sides are equal, and equilateral, where all three sides are equal. You should also know the names of triangles by angle measure. We have acute triangles. All angles are less than 90. A right triangle, one and only one angle equals 90. And an obtuse triangle, one and only one angle is greater than 90 degrees. The bigger part of this section was the exterior angle theorem. Which states that the exterior angle in a triangle is equal to the sum of the two remote interior angles. So if I give you a diagram as such, angle 1, angle 2, 3, and 4. Of course, we know 2 plus 3 plus 4 equals 180, and 1 plus 2 equals 180, but the exterior angle theorem says the exterior angle, which is this angle 1, equals the sum of the two remote interior angles, which are 3 plus 4. Don't forget, remote means far away from. So it's not the adjacent angle to 1, angle 2, it's angle 1 equals 3 plus 4. That can be useful to solve some problems. They can be numerical, or so you can see diagrams like this. And find x. So that would be 100 equals x plus 40. Of course, x would be 60 in that case. Or you could be given algebraic relationships. Maybe 3x plus 4, 60, and x plus 10. I'm just making that up. So 3x plus 4 equals 60 plus x plus 10. So familiarize yourself with those types of questions. And also there are many questions in book, on quizzes, on tests, where you could be given some diagram like this. As I recommend, anytime you have an angle in the diagram, you want to find any other angle in the diagram. You've been asked to find it. So for example, if this is 50, so for problems like this, you want to consider any time you see a right angle on one side of a line, you want to put in a right angle on the other side of the line. You want to look for vertical angles, you want to look for triangles. Anytime there's a triangle where you know two angles, you want to put the measure of the third angle. So we have a 50, 90 triangle right there, so we know that this angle up here must be 40 degrees. Well, now we have this little triangle here. If we have 40 and 90, this piece must be 50. By vertical angles, that piece is 50. By linear pair, we have 130. And now we can finish off the problem. If you have two angles in a triangle, this triangle, 50, 90, this one is 40, and this top little triangle, 20 and 30 is 150. So this piece is 30. So make sure you consider that when you solve problems like this. Once again, for vertical angles, is linear pair, half circle. So if you have a segment like this, you want to consider these three angles equal 180 as well. And then the last section, 3.5, we look at the sum of the interior angles in a convex polygon. And for our purposes, we'll just say for a polygon, we'll assume it's convex. And that's the formula. As the nerve sides get larger, the sum of the interior angles gets larger as well. So that formula is n minus 2 times 180. That equals the sum of the interior angles. So if you're given n, for example, if n is 12, you want to find the sum of the interior angles, you just stick it into the formula. So n is 12, and 10 times 180 is 1800 degrees would be the sum of the interior angles. Then if that's the sum of the exterior angles, well, this is actually quite easy because it's a constant. No matter, and this is, once again, in a convex polygon. The sum of the exterior angles is always equal to 360 degrees. So if they ask you a triangle, what's the sum of the exterior angles? You say 360 degrees. If they give you a pentagon and they ask you what's the sum of the exterior angles, you see 360 degrees. Can't be any easier than that. Just make sure when you read the question, exterior and interior, right, only different by the first two letters, so make sure you read the question carefully. I would tell you to circle sum and exterior, interior when you do this. Because then when you get to figures which are regular polygons, they're polygons where that is equal sides and equal angles. So it is equiangular and equilateral. Well, if all angles are equal, therefore if you want to find the measure of one interior angle, you can do the sum formula, which is n minus 2 times 180 divided by n. Similarly, if you want to find one exterior angle, you can do this respective sum formula, which is just 360 divided by n. So you can be given problems to solve for this. And so for an example of this. Suppose you have a 10-sided figure, and it's a regular polygon. If they ask you what's the measure of each exterior angle, well, that's the same as saying what's the measure of one exterior angle, right? So these mean the same. So if you want to, that's not a division sign. If you want to find each exterior angle, or if you want to find the measure of one exterior angle, then what do? Well, you would take your sum formula of 360, you would divide it by 10, and so each exterior angle is 36. And actually, this can help you find an interior angle. So I'm not going to draw 10 sides, I'm just going to draw a few sides that's not regular. So let's just say that our exterior angle was 36 for this problem. And I realize this is a pentagon, that's not the case. But if it was a 10-sided figure, this exterior angle goes there. Well, therefore, how can you find one interior angle? Well, they're supplementary, they form a linear pair. So therefore, wouldn't the one interior angle just equal 180 minus 36? And therefore, I could say each interior angle is 144. An alternative way to find one interior angle in a regular polygon, which is the same as saying each interior angle in a regular polygon, is to use the formula n minus 2 times 180 divided by n. So this is much more complicated, but if they gave the same problem, if n equals 10, what can we do? Well, we'd do 10 minus 2 times 180 divided by 10. And if we did that math, the one interior angle would be 144 degrees. And of course, from that, if you want to find the one extra angles we did before, you could do 360 divided by 10 to be 36. That's one exterior angle. And here we have the one interior angle. We can see the exterior angle and the interior angles are supplementary. So if you remember that one exterior angle plus one interior angle equals 180. So if you know either one of these, if you know the exterior angle, you can find the interior angle, or if you know the interior angle, you can find the exterior angle. This is a very quick method to find the one interior angle. Because if I have two choices between using this formula and this formula, and the formula on the left is for one exterior angle, and the formula on the right is one interior angle, well, I'm going to use this formula because it's a much easier formula. Even if I'm asked to find one interior angle. So, for example, if I'm asked to say a 20-sided figure, even if I'm asked to find what's one interior angle, well, I'm going to find the exterior angle first. So it's 360 divided by 20. So it's going to be 18 degrees. And if I do what I said before, if I know they're supplementary, well, 180 minus 18 is 162. And therefore, this would be the measure of one interior angle. Because once again, one exterior plus one interior angle, they are supplementary. So I think that's a very easy way to do that. So let's just review. You have to know the formula, n minus 2 times 180. That equals the sum of the interior angles in a polygon. It does not matter if it is a regular polygon or a non-regular polygon. It's all the same. If you want to find one exterior angle, I would do 360 over n. If you want to find one exterior angle, one interior angle, my preferred way is actually not to use the formula n minus 2 times 180 over n. It's to say 1 exterior plus 1 interior equals 180. I would find the measure of the exterior angle using this formula, and I would just subtract it from 180 to find the interior angle. Another concept on this chapter was convex polygon versus non-convex polygon. First of all, we know a polygon is a closed figure with straight edges, so this is not a polygon. It also, you can't have segments that intersect other than at a single vertex. So anytime you have a vertex where there's more than 2 segments coming into it, that is also not a polygon. Our polygon, a convex polygon, is something that if you connect any point on the boundary inside the figure, or 2 points on the boundary of the figure, or 2 points inside the figure, no matter how you construct it, when you draw that new segment, if all those points lie on or in the figure, then it is convex. If you have a figure like this, which is still a polygon, right, it's a closed figure with straight edges. At any vertex, only 2 segments come into it. If you can choose 2 points in the figure or on the boundary of the figure, and if you connect them, if there is a segment drawn where part of that segment is outside the figure, such as there, then that implies this is non-convex. Review the proofs. There are 2 types of proofs you'll have to typically. I can give you parallel lines, and I can ask you to prove something about maybe 2 angles being equal. If that's the case, you want to use the alt-interior angle theorem, same side interior angle theorem, or corresponding angle postulate. The opposite side, though, is when I give you just some information. There's no diagram here, you can't reference this, and I ask you to prove 2 lines parallel. This is when you work backwards and write the goal, and I mentioned this earlier in the video. The goal, you want to state which angles would be equal or supplementary. If the lines were parallel, then you want to prove that goal, and then your last step is to state the lines are parallel, and that's by the converse of any of those 3 theorems. Converse of alt-interior angle theorem, or converse of same side interior angle theorem, or converse of corresponding angle postulate.